Alright, in this video we're going to look at examples having to do with inequalities in a triangle, specifically side lengths and angle measurements. When given the lengths of two sides of a triangle, how are the possible lengths for the third side determined, and how are the inequalities involving the sides and lengths of a triangle used to make comparison, are the central questions for this video in the examples that you're going to see and work through. So let's rank the angles of this triangle in order from the least angle to the greatest angle. We're going to look at the corresponding side lengths that go with the angle. So if we rank our side lengths in order from least to greatest, so side BC, this is the shortest side length here at 9.5. Side AB is the second shortest side, and then obviously AC is the third shortest or the longest side at 11. So now the angles that correspond to these side lengths, the angles that are opposite, so angle A here corresponds with the side length 9.5, angle C corresponds with the side length 10, and then angle B corresponds to the longest side 11. So that's going to be our order ACB. And there's your answer choice D. Okay, now let's go for the side lengths in order from least to greatest. Well, quick calculation here is going to give us the missing angle measurement, which looks like 62 degrees. Quick calculation, a 60, 60, 60 equiangular triangle. Since 58 is 2 less than 60, we know angle C has to be 2 more than 60. Quick calculation there. So now the side lengths, or sorry, the angle measurements, here is our least, right here, angle A. Here is our second least, angle B, and then here's our greatest angle, angle C. So the opposing side lengths should be in that same order, least, middle, and greatest. So looking at our answer choices, D is the right answer there. Okay, find the shortest segment in the drawing, and don't just guess based on the appearance of the diagram. You should know that by now. The figure is not necessarily drawn to scale. So let's see if we can't calculate some missing angle measurements that is going to help us determine the shortest segment. In this, the sort of top left triangle, we're missing a 49-degree angle, and in this angle D at the bottom right, this is a 21-degree angle. So now comparing side lengths, comparing angle measurements to side lengths, here in triangle ABC, we have the shortest side being BC. It's opposite the shortest angle, 38. BC is the shortest side. BC is shorter than AC, in fact, because AC is opposite actually the largest angle in that triangle. Now if we look at the triangle on the right, maybe I'll do that in a different color. Here's the triangle on the right. The smallest angle, angle D, right here. So in this triangle, AC is the smallest side length. But we've also already determined that side length BC is shorter than AC because of this top left triangle. So BC has to be the shortest segment in the drawing. Okay, how about the longest side in the figure below? Let's follow the same approach we just did. So again, we'll take a look at this triangle here. We've got a 60, a 55, and taking the 5 degrees from 60 and putting it to this angle here kind of works again. In this triangle, 55 is we're looking for the longest side. 65 is the largest angle. That's going to make side length AB the largest or the longest side for triangle ABD. Now, how about the right triangle, not the right triangle, but the triangle positioned on the right here, triangle BCD? We're missing an angle measurement of 55 right here. So the longest side length in this triangle actually is BD, the side that's shared by both triangles. So BD is the longest side for the triangle BCD, but we've already previously determined actually that side length AB is even longer than side length BD because of this triangle on the left. Therefore, we've got our segment AB. Can a triangle have lengths 6, 7, and 9.5? We remember the test here being no segment length, no side length is less than the difference of any of the other two, and no segment length is greater than the sum of the other two. So 6 plus 7 has to be greater than 9.5. So like the largest side has to be less than the sum of the other two. So that certainly is true. So good. So far so good. And then the smallest angle has to be greater than the difference of the other two. So 6 is greater than 2.5. Okay, so far so good. Largest side is good, shortest side is good. So this definitely can be the lengths of a triangle. How about these examples here? 16, 27, and 10. Well, look at our longest side. 16 plus 10 has to be greater than our longest side. 16 plus 10 is only 26. This is no good. 26 is not greater than 27. So the longest side is too long. We don't have a triangle. Okay, how about 17, 27, and 10? So we've just increased the last example. 17 and 10, is that greater than our longest side? Well, it's actually equal to, but it has to be greater than. So again, this is not going to work out. Let's find the range of values for the third side of a triangle if we know the other two sides are 12 and 18. Remember, the smallest side, the smallest possible length, is the difference between the other two. So 18 minus 12. Okay, that has to be the smallest, the minimum. And then the maximum, x can't be, that third side can't be any, it can't be equal to or greater than the sum of the other two. So this is looking like the inequality where your side length's between 6 and 30. Sure enough. Answer choice B. Now if we have two sides whose length is the same, we're going to do the same thing. We want the difference to be the minimum, and we want the sum to be the maximum. So this means x is greater than 0, less than 40. Well, that's great. Notice answer choice A is similar to answer choice D, but also allows for negative values for x, which we don't want to. We don't want to consider negative side lengths for a triangle. All right, what could be the values for x? Now notice in the diagram the congruent side length. So we're talking about an isosceles triangle, at least isosceles, so where both of these side lengths are x. Now, knowing these two side lengths, the the sum of them, x plus x, can't be greater than or equal to 50. So that these need to be less than 50, right? They need to be less than 50. So 2x has to be less than 50. X has to be less than 25. I've got that backwards. Let me correct these inequalities. No, x has to be greater than 25. The sum of these two sides has to be greater than that third length. And of course their difference, which is 0, is less than 50. So we're looking at values for x that are greater than 25. That's going to match our answer choice A much better.